This lesson examines one type of hypothesis test, the difference of means test. My objective here is to help you, first of all, understand the logic of hypothesis testing overall. So in practice with an actual study, what are alpha values, also known as your significance level? What are p-values? And what do type 1 and type errors look like in practice? So we'll be coming back to some of these same concepts of hypothesis testing when we discuss regression. We're first starting with difference in means just to help you really internalize what those actually look like. So what is a difference of means test? This is a type of hypothesis test that examines whether two groups are different on another variable. So it's a way to see if there's a statistically significant relationship between these two variables. And so you ask, does a party ID, being Democrat or being Republican, affect your feeling thermometer for Obama, right? So you're asking, do Democrats in general feel more positively towards Obama than Republicans would? So to do this, you would calculate what the mean feeling thermometer is for Obama among Republicans and the mean feeling thermometer among Democrats for Obama, and then compare them. The key here is to look at that and say, is this difference that we observe actually statistically significant? Can we conclude that this difference is not simply due to chance? So this kind of test is most appropriate when your independent variable is categorical. Again, party identification, right, is Democrat or Republican. And then your dependent variable is interval or ratio. This is because you're calculating what that average is, right? So feeling thermometer is an interval variable. So you're able to say, Republicans have a feeling thermometer for Obama of 34, and Democrats have a feeling thermometer of 55, something like that, right? You're able to quantify it in that way. So what are the steps involved in actually doing a difference of means test? First, as with any hypothesis test, the first step is to select your significance level. Again, alpha of 0.05 is pretty standard in political science, so this is up to you. You select your significance level. Second, you calculate the mean and standard error for each group on that dependent variable. For our example, that was the feeling thermometer for Obama, right? So you just start by collecting those and calculating them. Then you calculate the confidence interval for each of those two groups on your dependent variable, right? So remember, go back to the confidence interval lecture if you need a little bit of refreshing, but here the confidence interval is equal to the mean plus or minus 2 standard errors, okay? So that's if you have an alpha level of 0.05. You're going to use that 95% confidence interval. Fourth, you actually compare the two confidence intervals, the confidence interval for Democrats and the confidence interval for Republicans, and if they overlap, that means that you can't reject the null hypothesis. It means that the relationship between the independent variable and the dependent variable is not statistically significant. And that's because you see that they potentially overlap, that you can't conclude that there really is a difference between them. There might be one in your sample, but you're not positive that there is one in the overall population. So here are these 4 steps. We're going to go through them for that example that I've mentioned. We're going through them with an example of what your ruling party is in a municipality and how much they spend on education. So here's a question. Does the mayor's party affect per capita municipal spending on education? Okay. So here, your dependent variable would be spending on education, right? Independent variable would be the mayor's party. So just note here, the dependent variable is a ratio variable, right? Because it can range from 0 on up. And the independent variable is a categorical or nominal variable. The null hypothesis in the scenario is that the mayor's party has no effect on spending for education. Right? That even if you observe something in the sample, that in practice, in the population, there is no effect. Versus an alternative hypothesis, which is that the party has an effect on education spending. Okay, so we've set up the components of our hypothesis test here. So So let's go through and think about how we do this in this study and how we would do a difference of means test. So we're randomly sampling 200 municipalities. And we find that education spending in municipalities with a Democratic mayor have this level. The mean is $4,800 with a standard error of $300. Okay. And then we look at Republicans, Republican mayor-led municipalities. So here, it's higher. That the spending in these municipalities is $5,400 with a standard error of $100. So if we just were to simply look at this from our sample, you might say, oh yes, Republican-led municipalities spend more on education. The question we have to ask now is this simply due to some sort of chance that we collected in these municipalities, the ones that we collected have this greater level of spending for Republicans, or is there really a relationship here, right? So is there a relationship between ruling party and spending on education at a 0.05 significance level? So we're never going to be able to be 100% sure about what the population is, but we can be 95% confident that there is or is indeed a relationship that we could reject the null hypothesis. So to do this, we first calculate the 95% confidence interval for each set of municipalities, for the Democratic municipalities and for the Republican municipalities. So that is, again, mean plus or minus 2 standard errors. So for the Democrats, this is 4,800, right? That's their mean, plus or minus 2 times the standard error. So I just gave you the standard error here. And that means that in the population, we're 95% confident that the true population mean among Democratic-led municipalities is between $4,200 and $5,400 that is spent on education. Likewise, do the same thing for Republicans. So there, the mean is $5,400 plus or minus 2 times the standard error of 100. So there, it's between $5,200 and $5,600. Just point out one thing here. We're looking at the standard error for each subset, right? We're looking not at the overall standard error, but the standard error among Democratic-led municipalities and the standard error among Republican-led municipalities. And that's because, as we see here with the Democratic-led municipalities, there's much greater variation than there is among the Republican-led municipalities. So you're not doing one standard error, you're calculating 2 different standard errors and using those separate standard errors in your calculus. So if the confidence levels overlap, we cannot conclude that there is a statistically significant relationship. So here I've mapped out what this actually looks like to visualize a little bit better, right? So here we have the Democratic-led municipalities. And again, I said the 95% confidence interval was between $4,200 and $5,400. So here's the mean of our sample right there. And then we're pretty certain that somewhere within this band. So our standard error was pretty big, 300, and so that means that we had a pretty big band here. We weren't entirely confident about exactly where it was. It's going to be somewhere in this wide band. And this is the 95% confidence interval for Democratic-led municipalities. Republican side, the mean was 5,400, and the band was between 5,200 and 5,600. It's much tighter. Maybe that's because Republican-led municipalities are more homogenous than Democratic-led municipalities, which can range from, say, Cambridge, Massachusetts, it's a fairly wealthy community, to a small town in the Rust Belt of Pennsylvania, right, that may have fewer resources. So here, this is a much tighter band. So we're 95% confident that it's in between these 2 bands. So visualizing what we do with a difference of means test is that we look at where or whether these bands overlap. And here we see that there is indeed overlap, right? That most of the band is not overlapping, but there is this portion here that overlaps between them. So what this means is that we cannot conclude that the difference is simply due to chance, right? So let's go through the conclusions here. We find that our results are not statistically significant. Remember, Statistical significant means that your p-value is less than your alpha, your significance level. And our significance level was 0.05. So I'm just making this up here. Let's say the p-value is 0.18. Remember, you don't have to actually calculate this. Your statistical software will calculate it. But you need to draw the conclusions of what to say when you have a p-value of 0.18. So that means that at a significance level of 0.05, we can't reject the null hypothesis. We can't say that the difference in our sample is because Republican and Democratic municipalities are actually different. We have to say that it still could simply be due to chance, due to sampling some particularly crazy municipalities in either category. But here's the important thing to keep in mind. We could have a type 2 error here. It is possible that ruling party affects education spending. We did see something in the mean, right? That the means of our samples were indeed different, but we aren't confident enough to reject the null hypothesis. But it doesn't mean that in the real population there isn't a relationship, just that we can't do that. So one way that you might get around this problem, if you're looking to show, you're looking to make this argument, is that you could collect a larger sample to reduce your p-value. Maybe you got some flukes in there, some particularly low spending Democratic municipalities, or particularly high spending Democratic municipalities. So if you collected a larger sample, remember from the law of large numbers, and from we know that we're going to be getting closer to what the actual population looks like. And so as you collect a larger sample, you'll be able to reduce your p-value and be able to come up with statistically significant results if we are making a type 2 error here.